students, welcome back to Wisdom Academy YouTube channel. In the previous video, I have talked about introduction of light. There I told you what is reflection, what is a mirror, different types of mirror. I talked about virtual and real image, and then I talked about the characteristics of the image found by a plane mirror. If you have not seen that video, please go and see that video first. And now I am going to talk about reflection in spherical mirror. So, if you see my previous video, I have talked about what is a spherical mirror. It is a mirror derived from a spherical glass. So, from there, if I cut out a portion of the sphere, in that if I polish from outside and make the inner part as reflecting, it is known as concave mirror, and vice versa. If I paint the inside part and keep the outside part as reflecting or the bulged part as reflecting, it is known as convex mirror. Today, before starting the image formations, I want to talk about some basic terms of the mirror, spherical mirror. So, I said you that any spherical mirror, like this is the spherical mirror, it is derived from a sphere of glass. So, whenever there is a sphere of glass, there will be a center for this, isn't it? Any sphere will have a center. That center is known as center of curvature. That center is known as center of curvature. I will write here C as center of curvature, right. Next, if now I will erase this part because we have understood that the center of curvature, how it is defined. So, how we will define center of curvature? It is the center of the sphere from which your mirror has been derived, from which your mirror has been taken. That center part is known as center of curvature. If there is a line which is passing through center of curvature and it is cutting the spherical mirror at any particular point, this ray is known as principal axis. So, what is principal axis? It is the line joining the center of curvature and intersecting the mirror at any one point. This is known as principal axis. Principal axis. Then there is a next point. Let me consider this mirror to be concave mirror. Right. Now, any ray which is coming from infinite, and if it is parallel to the principal axis, then it will pass through a particular point. That particular point is known as focus. That particular point is known as focus. So, what is focus? Focus is the point at which any ray passing through parallel to principal axis gets converged, right, in the case of a concave mirror. This point where the principal axis intersects the mirror is known as pole. It is known as pole. Distance of pole or distance of center of curvature from the pole is known as radius of curvature. So, what is radius of curvature? It is represented by capital R, radius of curvature, and what is that? It is the distance of center of curvature from the pole. Remember my words, I am not saying distance between center of curvature and pole, I am saying distance of center of curvature from the pole. Why I am saying this? It will be more clear when I go to sign convention, right. Second thing, what is if focal length? That is the distance of focus from the pole. So, the distance of focus from the pole is known as small f, and small f is known as focal length. I will repeat all these points once again. What is center of curvature? It is the center of sphere from which your spherical mirror has been derived. Any line passing through center of curvature and intersecting the spherical mirror at a point is known as principal axis. The point at which the principal axis cuts the mirror is known as pole. The point at which the ray coming from infinite and parallel to principal axis gets converged is known as focus. The distance of center of curvature from the pole is known as radius of curvature, and distance of focus from the pole is known as focal length. All these definitions I expect you to write in your own words in your notebook. So before learning about the image formation, we must know what are the rules of image formation. Let us see one by one. I will tell both in the context of concave mirror and convex mirror. The first rule of image formation says that any ray which is passing parallel to principal axis will either converge to focus or it will diverge and seem to pass through the focus. Let us see what I am meaning. So if it is a concave mirror and suppose this is the principal axis cutting at pole and any ray passing parallel to principal axis, what will happen to this ray? It will pass through focus, this focus. Suppose the same thing in the case of a convex mirror where the inner side is polished. See, though the inner side is polished, but the center of curvature remains on this side only, focus remains on this side only. So what will happen? There is a ray coming parallel to principal axis, it will get diverged to some direction, but if you extend back side, it will seem to pass through focus. This is a virtual ray, right? This is the first rule. It says that any ray passing parallel to principal axis will converge to focus or diverge and seem to pass through the focus. Second rule of image formation says that is the vice versa of this. That is, any ray which is passing through the focus, it becomes parallel to principal axis. So any ray, if it is passing through focus, it will become parallel to principal axis. So this is the focus, suppose, and there is a ray which is passing through the focus like this. After getting reflected, it will become parallel to principal axis. That is the second rule. So any ray which is passing through focus, it will become parallel to principal axis. If I draw the same diagram in context of this, so if this is the convex mirror and a ray which is supposed to be passing through the focus, it will become parallel to principal axis. This is the second rule of image formation. Third rule of image formation says that any ray which is passing through center of curvature gets reflected back on the same path. So suppose there is a concave mirror and suppose this is the focus and this is center of curvature. Any ray which is passing through center of curvature like this, it will go back in the same path. On the path it came, it will go back in the same path. Same way, if this is the convex mirror and suppose this is focus and this is center of curvature, any ray which was supposed to pass through center of curvature, it will reflect back in the same path, right? So I will repeat these three rules of image formation. The first rule says that any ray which is coming parallel to principal axis will pass through focus or seem to pass through focus. Any ray which is passing through focus becomes parallel to principal axis. Any ray which is passing through center of curvature or seem to pass through center of curvature will reflect back in the same path. So just now we learned what are the rules of image formation. Out of those three rules, you can use any two rules and form the image. I will tell you how it gets formed. So any two rays at the point of their intersection, they will be the image formation. So I will take any two rules, either I can take the first rule or second rule, or second and third, or first or third, any two rules I can take and I can form the image. Now I will see in the various cases how the image gets formed. What I will do, I will keep the object at various different locations and I will see where the image gets formed and what is the nature of the image in each case. So I will start with the first case where the object is placed beyond C. So first I am learning about the image formation by a concave mirror, and the first case I am taking as object is placed beyond C. So first what I will do, I will draw a concave mirror. My suggestion is, when you are drawing any concave mirror, try to keep this aperture as less as possible. Don't make it more curved, then you will have problems in image formations. This is the pole, this is the principal axis, there would be focus and this would be center of curvature. This is focal length and this is radius of curvature. Remember one thing, always radius of curvature is 2 times the focal length. Very, very important point. If focal length is 10 centimeter, radius of curvature will be 20 centimeter. Why I am telling you that thing? Because whenever you do image formation, you must draw a diagram in proper scales. If you are taking this as 6 centimeter, you must take this also 6 centimeter. If you are taking this 10 centimeter, you must take this 10 centimeter. 5, this also should be 5. If you don't take this in the accurate measurements, your image formations will not be accurate. So I will repeat once again, R is 2 times of focal length. So always draw these two distances of equal length, right? The first condition is object is placed beyond C. So I am keeping the object somewhere here like this. Now what I will do, from the tip of the object, I will pass 2 rays and I will see after reflecting where they are meeting, after getting intersected where they are meeting. So I will choose the first rule of reflection. The first rule of reflection says that ray passing parallel to principal axis will converge to focus, right? So this ray which is parallel to principal axis, it has converged to focus. Second rule I will take is ray passing through the focus becomes parallel to principal axis. It goes like this. So see where they have intersected, they have intersected here. So where they have intersected, there will be the head, right? So head is in which direction? Down direction. So this is the image. If this was A, B, this is A dash, B dash. I hope you have understood how the image is formed. You can see once again to understand that I have taken an object AB and from its tip A, I have passed the ray parallel to principal axis which has passed through the focus. Second ray I have passed through the focus which became parallel to principal axis. I have found their point of intersection. Where the point of intersection is there, since started with the head will be formed. And from the head I will draw a straight line. I have drawn a straight line. I have got the A dash, B dash. If you see carefully the nature of the image, you would have come to know that its nature, whenever you write the nature, you must write its position. Then you must write its characteristics and you must write its size. So first position, where is the position? Position is between C and F. So where it has formed? It is formed between C and F. What is its characteristic? It is real and inverted. Why I am saying real? Because the rays have really met to form the image, isn't it? So it is real and obviously it looks inverted. And the third thing is its size. See, this size is bigger, this became small. So I will write diminished. Size has become diminished. So this is the nature of the image formed when the object is placed beyond C. Second case, the object placed at C. When the object is placed at C, let us see how the image will be formed. So once again I am taking a concave mirror. I am drawing the principal axis here. This would be the pole. Let me take this as focus, take this as center of curvature, and I am keeping the object at center of curvature. So remember that all these things you must draw in proper scale, then only you will get the image formation correctly. I am repeating once again, all these diagram formations must be drawn with scale, pencil and with proper dimensions, otherwise you will not get the diagrams correctly. So first ray from the head I am passing parallel to principal axis. First rule says it will pass through the focus. Second rule says if it is passing through focus, it becomes parallel to principal axis. I have done that. Passing through focus became parallel to principal axis. And what do you see now? I see that the object AB, it has met at this point, and when I am drawing, it is at the same point. So AB dash also has formed at the same C point. So what is the nature of image what you have got? The nature of image, the first thing is position. What is the position? At C. So you can remember that if the object is placed at C, image will also form at C. Second, its characteristic, definitely it is real and inverted. As it is seen, it is real and inverted. And what is the size? See, AB and A dash B dash have same size. So I can write here the image is of same size. Next, we will keep the object between C and F. So first I kept the object beyond C, then at C, now between C and F. So let this be the concave mirror, let this be the principal axis, this is focus, this is center of curvature, and I am keeping the object somewhere between C and F. Let me see how the image is formed. First rule, the ray passing parallel to principal axis, it will pass through focus. Second rule, passing through focus becomes parallel to principal axis. Now see where the rays have met, here. So if this is A, B, this will be A dash, and here the head will be there. So I will draw tail here. Very clearly it is seen that it is enlarged image. So what is the nature of the image? If I want to write, the first thing is position. Position is beyond C. So when the object is between C and F, the image is formed beyond C. Second thing is its nature, again real and inverted, very clearly visible, it is real and inverted. And third thing is its size, which is enlarged. So I can write it is enlarged. Now we will go to the next case. So what I will do now, I will keep the object at F. See, first I kept beyond C, at C, between C and F, I will go at F. So now I am going to keep the object at the focus. So let us see what will happen. This is the focus, this is the center of curvature, principal axis, this is pole. So now I am going to keep the object at focus. See, I am keeping it here. So first ray, it goes parallel to principal axis, it will pass through focus, no doubt in that. Now second ray, can I pass through focus? No. So here you have to remember that I cannot use the second rule of image formation where I had passed the ray through the focus. So I will go for the third rule of image formation. What it says, any ray passing through center of curvature will reflect back in the same path. So if any ray is coming like this and passing through center of curvature, it will reflect back in the same path. If you see these two rays, will it ever meet? It will never meet. So came like this and it goes to infinite. So if I write the nature of the image formation, then where the image is getting formed? At infinite, at infinity. What is the characteristic of the image? You can see, since it is forming on this side, I can write very boldly, it is real and inverted. And what is the size? Highly enlarged. It is highly enlarged. Now we have seen how the image was formed when the object was placed beyond C, at C, between C and F, at F. Now we will take the object between F and P, focus and pole. Let us see how the image formed. This is very important ray diagram which generally students will do mistake. So please be very careful in this. So this is the concave mirror, and this is the principal axis, this is the pole, this is focus, the center of curvature. So what I will do, I will keep the object between F and P. First rule, yeah, you can use parallel to principal axis, it will pass through focus. Second rule can I use? Again I cannot use. Third rule I will use. Third rule is passing through center of curvature will remain, go in the same path like this, right? Now it will not meet on this side, but definitely if I extend this rays, then it will meet somewhere on the virtual side. So if this was A, B, then this will become A dash, B dash. So the rays have not actually met, we have made it to meet. That's why I said this is a virtual image. Remember what I said about virtual? Virtual images are the images where the rays don't actually meet, but we make it to meet. This is a virtual image, and I said you also, virtual images are always erect. So what is the nature here? You can see nature. The first thing is position. Position is, it is inside the mirror or behind the mirror, whatever you want to say, you can say behind the mirror. Then what is its characteristics? It is virtual and erect. And what is its size? It is enlarged. So you can see very clearly that this is the only case of concave mirror where you got the image to be virtual and erect. In all the other cases, when it was beyond C, at C, between C and F, at F, you got the image to be real and inverted. This is the only case. So if you want to get a virtual image by a concave mirror, you must place the object between focus and pole. Please keep this in your mind. Then actually one more image formation can be done when the object is at infinity. So what I will do, I will keep the object at infinity and let us see where the image gets formed. So this is the concave mirror, and what I am doing now, I am just, this is the principal axis, pole, focus and center of curvature. I am assuming to be infinity. So from infinite, I will take one ray coming parallel to principal axis, pass through focus. Second ray also, I can take it to come parallel to principal axis, it will also pass through focus. So can you see both the images met at F. So what is the nature? You can see the nature was behind, no, first thing is position. Where is the position? Position is at focus. So image is formed at focus. Nature, as we know that the image is always real inverted if it is beyond this. So you can write by that way, the image is real and inverted. What is its size? It is highly diminished, or I can say point sized. It is very, very small. So if you want to make the image very, very small, point sized, we will keep the object at infinite, right? These are the image formations by a concave mirror. In today's lecture, we saw the rules of image formation. There were basically 3 rules. First rule was any ray passing parallel to principal axis was converging or seemed to converge to the focus. Second rule was any ray passing through focus became parallel to principal axis, and third rule was any ray passing to center of curvature gets reflected in the same path. Then we saw the image formations, and for different cases we made different image formations. You can also have a table like this in your notebook. Please make this kind of table, and if you have understood the concept within 3 to 4 classes, this will fit in your head. So whenever I say object is placed beyond C, you must say image between C and F, diminished, real, inverted. That should come in your mind automatically. So this table will help you in remembering that. So when the object was at infinite, image was at focus, nature was real inverted, size was point sized. Object beyond C, image was between C and F, nature same real inverted, size was diminished. When the object was at C, image also at C, nature was real inverted, size was same size. Object was between C and F, image was at beyond C, real inverted, enlarged. Object came at F, image went to infinite, nature was same real inverted, size was highly enlarged, and the object between F and P, image was behind the mirror, it was virtual and erect and was enlarged. So in the next session, we will learn about the uses of this concave mirror, where we are using it. We will also see the image formations by a convex mirror, and we will learn about the mirror's formula. Thank you for today's class.